ABCD is a rhombus with side length 6. The measure of angle ABC is 150 degrees. This is the angle ABC. Segment BE is perpendicular to base AD, and F is midpoint of segment BE. The length of a segment CF is expressed as common fraction in simplest radical form is a squared of b over c. What is the value of a plus b plus c? Now it seems obvious that to calculate a plus b plus c we need to know what a, b, and c are. And to get that we need to calculate the length of segment CF. So let's get started with that. So normally when we look at the problems in geometry and we don't know what to do, it's worth just trying to investigate the problem and find what we can find, okay? Well, let's start with angles. And we know that the side, well, ABCD is a rhombus. A rhombus is a parallelogram with all sides of equal length. And in parallelogram, opposite sides are parallel. So AD is parallel to BC. And if you look at the angle ABC, which we know is 150 degrees, and this angle BAD, those angles are same side interior angles. And for parallel lines like AD and BC, their sum should be 180 degrees. And since ABC is 150, BAE, this angle, is 30 degrees. The next thing we should notice that triangle ABE is a right triangle. So, and in the right triangle, again, sum of all angles should be 180 degrees. We know one angle E is 90 degrees, angle A is 30 degrees. In this case, this angle B, or ABE, should be 60 degrees. It doesn't have a choice. And now we got ourselves a right triangle that has angles 30, 60, and 90 degrees. And we actually should know a lot about this triangle. One thing we know, if we know one side of that triangle, we know the rest of them. In particular, we know that the leg that is opposite of 30 degrees angle, and 30-degree angle is this angle A, so the side leg opposite of this angle is BE. The leg opposite of 30 degrees angle is half of the hypotenuse. Hypotenuse AB in our case, all right? And AB is the side of the rhombus, and it's 6. So BE would be half of it, it means 3. Now look at the point F. Point F is the midpoint of BE. It means that BF is half of BE, and that is 3/2, so 1.5. Now, let's look at this triangle, FBC, okay? And that's a right triangle, because the angle B here is 90 degrees. How do I know it's 90 degrees? Well, one way to explain it is we have AD and BC, which are parallel, and BE is perpendicular to one of the parallel lines. In this case, BE is also going to be perpendicular to any other line that's parallel to AD. So it's perpendicular to BC. The other way to look at it is we know angle ABC, this red one, it's 150. We know this angle in an ABE in a triangle, right triangle. This angle is 60 degrees. So in this case, the angle FBC is, the difference between these angles. It's 150 minus 60 is 90 degrees. Okay? But since it's a right triangle, we can use Pythagorean theorem. We know BF, which is 1.5. We know BC, which is side of a rhombus, which is 6. Now we can take BF squared plus BC squared, and that's going to give us CF squared. And if you plug the numbers, you get 153/4. Now, 153 can be split into factors as 9 times 17. And now we want to take square root of this to get CF. And we get 3 square root of 17/2. Notice that 3, 17, and 2 are prime numbers. So really we cannot simplify this fraction anymore. Okay? So this fraction is in the simplest radical form. And it should be like this: a squared of b over c, which means that a is 3, b is 17, c is 2. Add them up and get 22.